Hello everyone, this is Dr.Prashanthi, Assistant Professor of Chemistry from Government Degree College for Women, Karimnagar. Today I am going to discuss about the carboxylic acids and their derivatives, that is the derivatives of carboxylic acids. In the previous parts, that is in the part 1, we have discussed about the carboxylic acids introduction, classification of carboxylic acids into mono, di, tri, etc. We have seen some examples, and nomenclature of carboxylic acids. And in the nomenclature, we have seen examples of both aliphatic carboxylic acids, aromatic carboxylic acids, and we have seen the two types of nomenclatures, that is the common system of nomenclature and IUPAC system of nomenclature. And in the part 2, we have discussed about the preparation of carboxylic acids and physical properties of carboxylic acids. And in the physical properties, we have discussed about the hydrogen bonding existing of acids as dimers and acidic strength of carboxylic acids. And we have seen the effect of substituents on the acidic strength of the carboxylic acids. We have also seen the comparison between the aliphatic carboxylic acids and aromatic carboxylic acid strengths. And in the part 3, I have discussed about the chemical properties of carboxylic acids. And in the part 3, in the chemical properties, we have seen a few reactions of carboxylic acids in which the hydrogen atom of the carboxyl group is involved, and we have seen a few reactions of carboxylic acids in which the OH group of carboxyl functional group is involved, and some reduction reactions we have seen, and decarboxylation reactions we have seen. That is, under decarboxylations we have seen Hunds-Decker reaction and the Schmidt reaction, and next Arndt-Weisstadt reaction and Hell-Vollard-Zelinsky reaction. All these chemical properties and all these types of reactions we have seen in the part 3 of carboxylic acids and derivatives. And now in this part 4, I am going to discuss about the derivatives of carboxylic acids. What are the derivatives, how they are prepared, and what are their properties. Let us see what are they. The acid derivatives. If the OH group of carboxylic acid is replaced with the other reactive groups, that gives rise to the products which we are calling them as acid derivatives. See, we know that the general formula of carboxylic acids is RCOOH. If this OH group is replaced with the other active groups, they gives rise to different products, and they are called as acid derivatives. Okay, suppose for example, if this OH group is replaced by say for example Y, if it is replaced by Y. Okay, if Y is a halide, if based on this replacement we have 4 different types of acid derivatives: acid halides, acid anhydrides, acid amides, and esters. If the OH group of carboxylic acid is replaced by halogens, okay, by halogens, then they are called as acid halides, that is RCO, RCOX, and this X may be chloro, bromo, iodo groups. Okay, general formula is RCOX. Suppose if this OH group of carboxylic acid is replaced by OC double bond O R group. If it is replaced by this group, then they are called as acid anhydrides, and the general formula is RCOO. See here, this part is from the carboxylic acid, and these are replaced by these are substituted in the place of OH groups. So there, if carboxylic acid OH group is replaced by OCOR group, then they are called as acid anhydrides. If the OH group of carboxylic acid is replaced by NH2 group, they are called as acid amides. General formula is RCONH2. If OH group of carboxylic acid is replaced by OR-alkoxy group, then they are called as esters. The general formula is RC double bond O R dash esters. Let us see one by one each. And before going to this acid halide, I will explain you that acid derivatives contain carbonyl carbon atom. See, all the acid derivatives, they contain carbonyl carbon, which is electron deficient in nature, and due to the presence of high electronegativity oxygen atom on this. See, this RC double bond O group, this is this is electron withdrawing group, and our oxygen atom is highly electronegative. Therefore, all these acid derivatives, they can be easily attacked by the nucleophile, and all these undergoes nucleophilic substitution reactions also very easily. Okay, we will discuss all these in the next few minutes. First, let us see about acid halides. Acid halides are the derivatives formed by the replacement of hydroxy group in carboxylic acid with the halogen atoms like chlorine, bromine or iodine. Okay, RCOOH plus X on treating with halogen atom, they are giving rise to RCOX. See how these are obtained. See, carboxylic acids on reaction with the phosphorus trihalides or phosphorus pentahalides or sulfuryl halides gives rise to acid halides. Here I have taken the example of phosphorus trichloride, phosphorus pentachloride and sulfuryl chloride. So if you see the examples, suppose acetic acid on reaction with the phosphorus trichloride, it is giving rise to acetyl chloride, that is OH group of carboxylic acid is replaced by Cl group, acetyl chloride is obtained. Okay, if you see the another example, this is propanoic acid. Propanoic acid on reaction with sulfuryl chloride, OH group is replaced by chlorine group. We are getting CH3, CH2, CO, Cl, and SO2 is released and HCl is released. This is propanoyl chloride is obtained here. Next, acetamides. Acetamides are the derivatives of carboxylic acids which are formed by the replacement of hydroxyl group of carboxylic acid with an amino group. If OH group of carboxylic acid is replaced by amine group, then we are calling them as acetamides. The general formula is RCONH2. Preparation. Ammonium salt of carboxylic acid on heating alone gives acid amides. Ammonium salt of carboxylic acids on heating gives acid amides. See, actually this is obtained when carboxylic acid is treated with ammonia. See, first when carboxylic acid is treated with ammonia, ammonium salt of carboxylic acid is obtained. This ammonium salt of carboxylic acid on heating loses water molecule. They on heating in the presence of any dehydrating agents, okay, like a phosphorus pentoxide, they lose water molecule and gives rise to amides. Suppose if you take for example acetic acid. Acetic acid on reaction with ammonia, first ammonium acetate is obtained, CH3COO NH4 plus. Okay, CH3COO NH4 is obtained, ammonium acetate is obtained. This on heating with the dehydrating agents loses water molecule and gives rise to acetamide In this way, acetamides are prepared from carboxylic acids. Next, acid anhydrides. Acid anhydrides are the derivatives of carboxylic acids which are formed by the removal of water when two carboxylic acids react with each other. See, Generally, when two carboxylic acids, see this is our carboxylic acid, and this OH group is replaced by OCO R group. If it is replaced by OCO R group, we are getting acid anhydrides, and these are formed when two carboxylic acids react with each other. That is, suppose if you take two carboxylic acids, H2O is lost in this way. H2O is lost, and RCO O CO R, RCOO C double bond O R is obtained. In this way, acid anhydrides are obtained by the loss of water molecule from two carboxylic acids. See, for example, here I have taken formic acid HCOOH, and this is acetic acid CH3COOH. When these two react with each other, water molecule is lost and HCOO COCH3, acetic formic anhydride is obtained. Next, esters. Esters are the derivatives of carboxylic acids which are formed by the replacement of hydroxyl group of carboxylic acid with an alkoxy group, that is RCOOH. OH group is replaced by alkoxy group. They are called as carboxylic esters. RCOOR is the general formula. See, here we are using this R dash because to differentiate the alkyl groups, that this is coming from the alcohol. So R C double bond O R dash is the general formula. And among all these acid derivatives, esters are found to be the most important type of acid derivatives because these esters are they are widely present in nature, and these are responsible for the pleasant odor and flavor of so many fruits and flowers. Suppose, for example, if you take apples. Okay, apples, the flavor of this fruit is due to the presence of isoamyl isovalerate. This is an ester. Because of this, the flavor of the apple is getting. And because of another example, I have ethyl butyrate. Because of this ester in peaches, the flavor of peaches is due to the presence of ethyl butyrate. And most of the fats of vegetable and animal origin are also esters, and these are derived from higher acids and glycerols, and mostly esters are found to be used in most of the organic synthesis, and therefore esters are thought to be the most important class of acid derivatives. Let us see the preparation. Carboxylic acid, when heated with alcohol in the presence of mineral acid, gives an ester. See, carboxylic acid is RCOOH. When reacted with alcohol, that is ROH, H2O is lost, and RCOOR dash is obtained, that is ester is obtained. We have one example here, CH3COOH. This is acetic acid. Acetic acid, when reacted with ethyl alcohol, this is C2H5OH. When reacted with ethyl alcohol, they undergo dehydration, that is one H2O molecule is lost and esterification takes place, that is H2O is lost and CH3COO C2H5, CH3COO C2H5, that is ethyl acetate is obtained. See, here the OH group of acetic acid is replaced by alkoxy group, that is here the hydrogen atom of this acid is replaced by ethyl group. Therefore, the name of the acid after becoming ester, it converts to ate sound, that is acetic acid. Ic acid is converted to ate, that is acetic acid is converted to acetate. And here the alkyl group that is obtained from that is obtaining from the alcohol is here ethyl. Ethyl group is substituted in the place of hydrogen of acid. Therefore, the name ethyl acetate, that is ethyl alkyl group, is substituted on the acetic acid and the ester is formed. Therefore, it is ethyl acetate. Next, till now we have seen the preparation of these acid derivatives. Let us see the reactions of these acid derivatives. First, reactions of acid halides. Among acid derivatives, acid chlorides or acid halides are found to be more active. Okay. For example, conversion into acids. Acid chlorides or any acid halide, here I have taken the example of acid chlorides. Acid chlorides are readily hydrolyzed with water to form acids. So, acid halides on hydrolysis gives rise to acids. We have example benzoyl chloride on hydrolysis is giving rise to benzoic acid. Next, conversion to amides. Acid chlorides on reaction with ammonia, they gives rise to amides. That is, a Cl group of acid chlorides is replaced by NH2 group of ammonia and we get acid amide. That is, benzoyl chloride is converted to benzamide. Next, reactions of acid anhydrides. Conversion into acids. Acid anhydrides, they undergo hydrolysis in the presence of either acids or bases to produce carboxylic acids. Acid anhydrides undergoes hydrolysis in the presence of either acids or bases to produce carboxylic acids. That is, acetic anhydride, I have taken the example, this on hydrolysis is giving rise to acetic acid. Say we know that in the preparation of acid anhydrides, we have seen that acid anhydrides are obtained from two carboxylic acids with the loss of one water molecule. Therefore, acetic anhydride on hydrolysis is giving rise to acids, two molecules of acids. Conversion to amides. Acid anhydrides on reaction with ammonia, they gives rise to amides. Similarly, like our acid halides, these acid anhydrides also on reaction with ammonia, that is this process is called as ammonolysis, gives rise to amides. Okay. And we have also some examples that acid anhydrides, if they react with alcohols, they gives rise to esters. Suppose for example RCOO R dash R plus alcohol. Acid anhydrides, if they react with alcohols or this process is called as alcoholysis, they gives rise to esters R C double bond O OR dash plus carboxylic acid is obtained. And these acid anhydrides on reduction with lithium aluminum hydride, they gives rise to two molecules of alcohols RCH2OH. Two alcohol molecules are obtained. Okay, and we have some more examples that acid anhydrides, when they react with phosphorus pentahalide or phosphorus trihalide or with dry HCl also, they gives rise to two molecules of acid halides. Okay, they can be converted into acids by hydrolysis, or they can be converted into amides by ammonolysis, or they can be converted to esters by alcoholysis. They can undergo reduction and gives rise to alcohols, and also they react with dry HCl or phosphorus pentahalides and phosphorus pentahalides, and they gives rise to acid halides. Here I have taken example of phosphorus pentachloride, and therefore it is giving rise to acid chloride. These are some of the reactions of acid anhydrides. Next, reactions of amides. Among acid derivatives, amides are less reactive because NH2 is to be removed in this process. In amides, carbon nitrogen bond acquire a double bond character due to resonance. See, on the nitrogen atom of acid amines, lone pair of electrons are present which participate in resonance. Therefore, carbon nitrogen gets a double bond character because of this resonance. And amides undergo acid or base catalyzed hydrolysis to produce carboxylic acids. That is, on hydrolysis in the presence of acid or base, they undergo hydrolysis and gives rise to carboxylic acids. That is, for example, see acetamide. Acetamide on hydrolysis in the presence of an acid is giving rise to acetic acid. That is CH3CONH2 is converted to CH3COOH. And acetamide on reaction with on hydrolysis in the presence of a base is giving rise to the salt of the carboxylic acid. That is, acetamide is converted to sodium acetate on reaction with water or on hydrolysis with water in the presence of sodium hydroxide. So, amides undergoes both acid catalyzed hydrolysis to give carboxylic acids and base catalyzed hydrolysis to give the salts of the carboxylic acids. Next, dehydration. Unsubstituted amides undergo dehydration in the presence of strong dehydrating agents to produce cyanides. That is, in the presence of dehydrating agents like phosphorus pentaoxide, amides undergoes or loses water molecules and gives rise to cyanides. Suppose, for example, acetamide on dehydration is giving rise to methyl cyanide. Next, we have also some more reactions that reduction of amides. If amides they on reduction with lithium aluminum hydride or sodium ethyl alcohol, they give rise to primary amines. That is, C double bond O is converted to CH2 group, CH2NH2, RCONH2 is converted to RCH2NH2. So, amides on reduction gives rise to primary amines. And amides also undergo a very important reaction which we study under the heading amines, that is Hofmann bromamide reaction. That is Hofmann bromamide reaction. This we study this reaction in the preparation of amines. See, in this reaction, amide is treated with any alkali and bromine, which gives rise to primary amine. Suppose, for example, if you take acetamide on reaction with the bromine molecule in the presence of any alkali, that is, for example, NaOH, gives rise to amine. Primary amine is obtained, CH3NH2. That is, in this process, one carbon atom will be less than the starting material, that the product contains one carbon atom less from the starting amide. That is, methylamine is obtained, sodium bromide plus sodium carbonate and H2O. This is the reaction of Hofmann bromamide reaction. This is the very important reaction of amides. Next, reactions of esters. Esters undergo only the hydrolysis and the hydrolysis of esters is of two types. Esters on hydrolysis produces carboxylic acids, and this hydrolysis can be catalyzed by both acids and bases. Therefore, they are classified or categorized into two types, base catalyzed ester hydrolysis and another is acid catalyzed ester hydrolysis. Let us see what is that. Base catalyzed ester hydrolysis. This reaction is also called as saponification, that is hydrolysis of esters in the presence of base is called as saponification. It is a reversible reaction. The ester is refluxed with the aqueous solution of a strong base resulting in the formation of carboxylate ion. In this reaction, the ester is first refluxed with the aqueous solution of a strong bases like sodium hydroxide, okay, which results in the formation of carboxylate ion. Next, see, this carboxylate ion does not react with the alcohol, therefore this is not a reversible reaction. See, example, general formula is RCOOR dash plus NaOH gives rise to RCOO plus ROH. Example, methyl acetate CH3COO CH3 on reflection with sodium hydroxide is undergoing hydrolysis and is giving rise to sodium acetate CH3COO and a methyl alcohol is obtained. Let us see the mechanism. See, in the first step, this nucleophile OH minus attacks on the electron deficient carbonyl carbon. See, we know that this oxygen is highly electronegative, so therefore it abstracts the electrons towards itself, that is it withdraws electrons present in between the carbon atom and oxygen atom towards itself, and therefore it gets minus charge and the carbon gets a plus charge. It becomes electron deficient. Therefore this OH minus goes and attacks on this electron deficient carbonyl carbon atom. Okay, therefore RCO minus OR dash and OH is obtained. Next, elimination of RO minus, that is alkoxide ion. See, again these electrons are shifted in between these two carbon and oxygen atoms, and this alkoxide ion is eliminated, and in this way we are getting RC double bond OH, that is carboxylic acid is obtained. And in the third step, the proton transfer from the acid to alkoxide ion takes place. See, again here alkoxide ion is RO minus. This abstracts a proton, that is H plus, from the carboxylic acid. Therefore these electrons present in between this oxygen and hydrogen are shifted onto the oxygen, and the hydrogen atom is lost as H plus. This O minus attacks this H plus and gives rise to carboxylate anion, and alcohol is obtained. The carboxylate ion is associated with sodium plus and gives rise to sodium carboxylate, and the Na plus this associates with the Na plus and sodium carboxylate ion is obtained. In this way, in the base catalyzed hydrolysis, we are getting sodium salt of the acid and alcohol. This is base catalyzed ester hydrolysis, which is called as saponification of esters. Next, acid catalyzed ester hydrolysis. This reaction is reversible. Esters, when heated with water in the presence of acid catalyst, that is sulfuric acid or hydrochloric acid, they undergo hydrolysis and gives rise to carboxylic acid and alcohol. See, for example, general formula RCOOR dash ester plus H2O in the presence of mineral acid is giving rise to carboxylic acid and alcohol. Here the example I have taken in is ethyl acetate, that is ethyl acetate. Ethyl acetate on hydrolysis is giving rise to acetic acid and ethyl alcohol. Let us see the mechanism. The first step of mechanism is the attack by H plus on oxygen atom of carbonyl group. In this in this acid catalyzed hydrolysis, H plus, see, we know that this is highly electronegative, therefore it abstracts electrons towards itself and becomes O minus, and therefore it abstracts the proton onto it, and COH bond is formed here, and as this is losing electrons, it is becoming electron deficient, therefore it gets a plus charge, that is electron deficient carbonyl carbon is obtained, or COH R dash. Okay, next addition of water molecule to electron deficient carbon atom. So as this is electron deficient, the water molecule with the lone pair of electrons on the oxygen atom goes and attacks on the electron deficient carbon atom. See here. Therefore, in this way we are getting RCOH OR dash, and this is the water molecule attached. Next, proton transfer takes place from water molecule to this alkoxy group here. See, the electrons present in between these two atoms are shifted onto the oxygen atom, and this H plus is shifted to the OR group, that is alkoxy group, that is the lone pair of electrons present on oxygen of alkoxy group abstracts this H plus proton. Next, elimination of alcohol. And see here in this from this, see here the alcohol is eliminated, that is H, this is OH group of this one. These electrons are shifted in between this carbon and oxygen, and and this alcohol molecule is lost, that is RCOH ROH is alcohol is lost. Actually I am explaining this step here only. I have given in the next step also, I will explain there. And here two OH groups are present on the same carbon atom, that is unstable. Therefore, this is electron deficient carbon, and this is fulfilled by the donation or the transfer of electrons from oxygen, from the bond between oxygen and hydrogen atom towards carbon and oxygen atom, and this H is liberated as a H plus, which we abstracted or which we used in the first step of the mechanism. In this way, RCOOH carboxylic acid is obtained. Okay, in the process, in the fourth step, alcohol is obtained. Okay, in the acid catalyzed ester hydrolysis, the products are carboxylic acid and alcohol. In the mechanism, in the fourth step, alcohol is obtained as one of the product. Okay, and as as the carbon atom having two OH groups is unstable, this is losing H plus as the proton, and here we are getting the carboxylic acid, and in the last step we are getting carboxylic acid as the product. In this way, the esters undergo two types of hydrolysis, that is acid catalyzed hydrolysis and base catalyzed hydrolysis. In the base catalyzed hydrolysis, alcohol and the salt of the carboxylic acids are obtained. In the acid catalyzed hydrolysis of esters, carboxylic acid and alcohols are obtained. This is all about the carboxylic acid derivatives. Here we have seen about the four types of acid derivatives, that is acid halides, acid amides, acid anhydrides and esters. With this, the total chapter carboxylic acids and their derivatives is completed by this fourth part. And finally, we will I will tell you few words about the uses of the carboxylic acids. Carboxylic acids, they are found to be useful in found to have so many uses, especially in food industry, where that is for example lemons contain citric acid, for example spinach contains oxalic acid, and mostly that is sodium benzoate is used as a food preservative, and ethanoic acid, that is acetic acid, is used as vinegar in food industry. Okay, and acetic acid is also found to be very important in the production of rubber, in textile industries, in dyeing industries, leather industries, and in electroplasting industries, etc. And these carboxylic acids are also found to be useful in pharmaceutical industries also, like for example aspirin. Aspirin is nothing but acetyl salicylic acid, and these carboxylic acids are also used, that is, for example, also used in manufacture of soaps and detergents, that is, sodium or potassium salts of higher fatty acids are used in the manufacture of soaps and detergents, especially the carboxylic acids like stearic acid and palmitic acid are used. And I have told you that under the heading esters, that esters have so many uses because of their pleasant odor. They are used in the perfumery industries also, and especially the esters of benzoic acid are used in perfumery industries. And lastly, in the manufacture of textiles also, example, hexane dioic acid is used in the manufacture of nylon 66. In this way, the carboxylic acids have so many uses in both the medicinal industry, in food industry, and in the organic synthesis, and in the synthesis of so many other organic compounds like esters, acid halides, anhydrides, amides, primary amines, etc., and alcohols, etc. With this, I concluded today's session. Thank you.